The camshaft lifters don't line up with the lobe. Now, the nice part is that it actually is doing nothing. They forgot to grind that surface right there. Who do you call and complain to? Nobody. You just fix it. In this video, you're gonna see us custom modify Viper V10 block. Hey, here's Steve Morris Engines. I am Steve. This is what a blown head gasket looks like on a Dodge Viper. This is Ben Black's engine. Now, we didn't build this engine originally. It blew a head gasket. Obviously right there. And so I thought I would show you some stuff on how we're going to be fixing this for Ben. And changing it and showing you what I think was, part of the problem or part of the issue. And it's pretty understandable. But this is a mid-sleeve design. I talk about this in the sleeves and how this is all open. And there really is no support out here except just right here. And there's nothing in the middle. I think that it's going to be, we're going to make it better. It's never my favorite, but I think after we're done with this, I think it's going to be pretty good. Better, I hope. So what I'll show you is, you can see here on the sleeve, what they did was they used a steel gasket. Well, they used a steel gasket and they put a copper O-ring in the top of the sleeve. Now, I understand why they, what they're thinking about that is, oh, I'll put this copper ring in there, and then when you put the head gasket on, it'll squish into it, and that copper head ring will, be more pressure into the gasket. It doesn't really seem to do that. The steel gasket's kind of made with this little wave. They kind of have their own little wave deal in there, which basically does that. And then the copper O-ring is so soft it doesn't really embed into anything. In fact, it is flat. I mean, you can't feel the copper ring in there at all. So it pretty much just flattens out and kind of doesn't do anything. I understand what's going on, what the thought process is on it. I've seen people do steel rings in here. In fact, that engine over there of Dennis Thomas's that we just got done doing the build-up video, that's what they had done. They put a steel ring in it. And then we're trying to get the steel ring to impregnate or emboss, however you want to say it, into the steel gasket. Well, the steel gasket is flaming hard and just doesn't quite do that. So what I'm going to do with this is we're obviously going to have to fix the block. And I thought, you know what, we're going to dry deck this all at the same time. And we're going to do that by welding up all these areas right here. Welding up this, welding up this, welding up this, then welding. I just started welding here, welding. And then we'll probably just machine and plug these outside water jacket holes. And probably the inside water jacket holes. We'll just drill, tap, and plug those. So we make this whole entire deck surface solid. And then when we put these sleeves back in and they're all machined in, I'm going to put a receiver groove, use a regular copper head gasket, and then put O-rings in the hoops in the cylinder head like we normally do. So I'm going to start welding this whole thing up, and then we'll put it up in the old CNC machine and then make this perfectly round again. And then we'll put the sleeves in, hone, and go at it from there. Now what I'm first going to do is got to clean. You cannot have what you're welding clean enough. And I'll probably do that by grinding. And then I'm going to grind out these little, just leave these little sharp tips out here. So I'm just going to grind that off because I really can't weld in there with that all there. So I'm just grind those off, and then start filling it with weld. Now you can see right here, it's basically what I'm going to have to do through this whole thing is, you see where I just welded up all right there. Now, the nice part is that it actually is doing nothing. Everything is going to seal up around the, everything's actually going to seal up around the sleeve and the top of the sleeve. So this is actually just making stuff flat just so it isn't doing anything funny with the gasket. And then filling all these areas here are just for the dry decking portion of it, so no water goes through here. And then we'll do the same on the cylinder head. Well, we're going to block all the cylinder head water jackets, and then we'll force water to come through right here. I think we'll have to put, we're going to put a fitting or a couple fittings, or we're going to try to figure something out here to go water from here to up to the cylinder head. So we're going to be figuring out exactly how we want to do all that, or we'll go through here. I still think that's still a reasonably good place. So anyways, we're still figuring out some of that stuff, what the best way and method would do. So I'm gonna be just finishing up welding this, and I'll show you the whole thing when it's done. Well, as you can see, I decided to said, screw it. It's pretty quick, actually, probably quicker than drilling and tapping these holes here. So I just filled that all in. So you can pretty much see what I got going on there. Filled up that whole radius, filling in the holes, building my little bridge pieces, and I'm gonna keep on going on, and I'll just come back and show you the whole thing complete. All right, here you go. Welded up deck. Now, nope, there's not a bunch of special stuff to do. Nope, you don't have to reheat treat. Nope, you don't have to do any of that kind of stuff. All of this is how would you say, it's non-critical. We're just plugging this hole. Who cares? We're just filling these spots. It's non-consequential, non-critical area dimensions. But we're only doing this just to make sure that this thing dry deck this. So actually I'm pretty happy with that. It takes a while to do all this welding, but I think once this is all machined and CNC machined, probably won't even really be able to see it, except for maybe some discoloration. That's about it. All right, now here on Ben's block, before we do all the machining on the deck surface for the sleeves, I'm also putting in roller 55 millimeter cam bearings. So what we do here is we put this up in the centroid, because it has 50 inches of Z travel on it. Is that 50 inches of Z travel? Yep. And this is the roller bearing that we put in it for a 55 millimeter all the way through, all the bearings. Because Vipers have a weird deal where there's no cam bearing in the front, and it's big, and then it goes smaller. It's kind of screwed up. So we're putting in these roller bearings and doing that. We've indicated, or Brock has indicated in the block off of the main saddles, right through here. Indicated the whole thing in. Then we'll give this a little machine haircut up here to flip it over and make it even easier. And then we bored these first three cam tunnels, flipped upside down, and bored the next 3 cam tunnels. Then we put it in the line hone and final line hone them to size. So something pretty cool right there of going in and doing the cam tunnel. You can see it in there. It'll come down and do this third one right there. So after we do that, then we'll put it over in the rottler, and we will do the bores and get the sleeves all reinstalled. And after we're done, it'll be dry decked, finished sleeved, and 55mm cam bearing. What we're doing here is we're working on the line hone now, so we have bored the cam tunnel in the big centroid machine. So we've bored it in the centroid, but you can't do a single pass. This is the whole problem with things, is you have to go one half of it, flip the block over, do the other half of it. So there's always a possibility of having a slight misalignment. So we leave a little bit of material in there so we can line hone it and make it straight. And it's actually pretty darn good. It's probably as close as I could figure. It's probably only about 0.5 thousandths off, or was about 0.5 thousandths off end to end. So now we're honing and checking size. So Cody, you want to go ahead and start checking size on there? You can still see we still got to put it in the machine and do the decking, boring, to get the sleeves back in it. So we're just working on this main tunnel right now to get this into a 55mm roller bearing, and then we're gonna just keep on sneaking up on this. Okay, so we have everything is really good here. And again, this is one of those machines, especially a line hone, and especially in a cam tunnel, that once something gets big, you can't make it small again. It's a cam tunnel. You can't clip it. You can't make anything smaller. So once the material's gone, it's gone. So what you have to do is we're flipping the block around, we're making sure, and then you really have to manipulate the stone and where you're honing in order to get the right position to take the mount out of one end or the other, or in the middle. So we are within 0.5 thousandths on all of them. Right dead nut zero, and this one here is 0.5 thousandths tight. But these two are at 0. This is like 1/10 or 2/10. This is like 3/10. This is like 3/10. So I can't get these without making these too big. And I can live with a 0.5 thousandth small on the bearing for the crush. Doesn't affect the clearance internally in the bearing or anything like that. So this is all done. So now we'll take this out, and this is going to go into the rottler, and we're going to start cutting the decks and the bores. But the cam tunnel is all set 55mm for a 55mm roller bearing, like so, like this. All right, proceed on putting it in the machine. Okay, we got Ben Black's Viper block finally up into the machine. That's my fault. Just insanely busy. So anyways, back to the reality here, which is Brock has got this thing up in the machine. So now we're going to, you see the video of me doing all the welding on this, everything that we did there. And now we are resurfacing it because we made this into a dry deck. So we're resurfacing it, going to cut the bores again so we can reinstall the sleeves and start going on to fixing the cylinder head. And I'll show you that right now. We'll go over there, walk, and see that, and then we'll come back and let you see how this thing gets all machined. Decks, comes in, does all that. It's going to come down, bore, and do all that stuff. So here's all the sleeves that we're going to be putting back in. And what you'll see here is after we get the sleeves put back in it, we're going to take this copper ring out that's in there that does not work, and obviously doesn't work because it blew the head gasket. We'll take this copper ring out. We're going to turn this into a receiver groove and then put the fire hoops into the cylinder head like what we normally do on our SMX stuff, SML stuff. So going to be really a much better setup. I like the sleeves that these are. It's a nice sleeve setup. It just sucks that it had water coming through it. So we've taken care of that and show you all the machine work and how this stuff all works. Okay, now you can see that we have the sleeves are in. We cut the sleeves to be 3 thousandths. Yep, 3 thousandths proud, which means it's sticking above the deck surface 3 thousandths. That's pretty normal. That way the gasket sandwiches and pushes into the sleeve and actually kind of makes another sealing ring all the way around it. And we've added the receiver grooves. Now the receiver grooves are a little bit funny here because we're going to pick out the rest of the copper O-ring that they had in there from somebody else. And so some of this looks a little funny because I'm not going to like re-weld this thing like 5 different times trying to get this perfect look, because what I wanted to do is just, we're plugging all the holes. So like right here where I didn't want to just take down a bunch of material just to fill that, because it's solid. There's no water that's going to be coming through there. But there's going to be little areas like right here, a couple of these little areas where we're actually just going to add a little bit of JB Weld to push in there, epoxy, to just make sure that we didn't have any little pinhole or anything there, because I want to have this perfectly sealed. But welding up a whole bunch of air like you saw was there is really tough. But it's actually machined all the way down. Just shows a couple little areas that are just a little bit funny. So anyways, this is decked, honed, the sleeves, dry decked. Now we are going to take this out and we'll be getting this into the cylinder hone and hone it. Alrighty, now we're going to do the cylinder head for Ben. And you can see here, this is, showed you how the gasket used to be and the hoops and the rings, no receiver groove here. And this is what happens. It just blows out in between the head studs. So head studs are right here. This is a washer and this is a washer. These are the head studs, water, oil drain. So we're going to plug, because we dry decked the block, showed you that. We're going to plug the water, plug all waters through here, make it circulate through the ends still. So it still has all the water in the cylinder head and in the block, but it's not going to be transferring through the gasket. So it wouldn't blow like this, even though this probably didn't blow any water out of it. It could. If it got bad enough, it just had to cross over there to get into water. It should be pretty common. Or if it blew on the inside, in between these two, it typically would go right through, dead center through the water. So anyways, I'm going to grind this out, weld this up, beat it in, then we'll resurface it, put receiver grooves in, or the hoops in it, I mean, and the receiver grooves are already in the block, and then we will tap and plug all the water holes here. Now what you can see here is that you need to use a carbide burr. You have to get all the contaminated aluminum off of there. Make sure that there's nothing, no little spots. Actually, we got a little spot right there I'll need to continue to grind out. But you don't want to use anything, any kind of sander, like a flapper wheel, like something like that, because it will impregnate sand into there and just makes it dirty. Can't weld dirty stuff. Has to be clean. So we need to get nice material. That's why I kind of did a little bit on the chamber side to make sure that it's clean over there. I'll probably even hit on the outside here just a little bit so it doesn't contaminate, bleed over. I don't know if that's the proper terminology or not, but I'll come in here and I'll grind that just a little bit more. And looks like I gotta get up there just a little bit too to make sure that there's no contaminated metal that I'm welding on. And then we'll start welding, add material. You'll see me beat it with a hammer, which kind of compacts it down. I think of it as forging, basically, because that's actually what a forge does. it beats it. So we weld, beat, weld, beat, weld, beat, weld, beat, and it leaves a nicer compact area. And whenever we do that and you beat it when it's hot, you don't ever really see it have, when we mill it, very rarely do we see little air pockets. If you don't, a lot of times you'll see little air pockets. Okay, you can see there we have the weld and the hammering. You see me hammer this. Clean, flat side of the hammer. So you see the weld there. Clean, flat side of the hammer. Not super hard, it's just enough to peen and make it compacted. That's what it looks like here. And I'm really kind of making sure that I'm working it right in the area of where the hoop is going to be. Back a little bit here from it. You can kind of see the hammered, peened look there. Let me grab a straight edge and we'll verify that it's all higher than it used to be. Alright. And it is all definitely higher. Okay. So I'm pretty good with that. Now we're going to put this thing in the machine. It's welded, peened. Looks pretty good in here. Not going to have to do much of anything at all. Alright, looks good. That's how you weld up a cast cylinder head. 50, let's see, what material is that? I use a 53-56 material. Cast head. There might be something better, perfect, I don't know, but really doesn't need to do anything out there, but I figure what the heck. You really don't need to preheat, post-heat, any of that kind of stuff. Since I'm remachining everything anyways, it doesn't really do anything. So this thing is, we're going to tap and plug, resurface, put the hoops in it, hit this chamber a little bit, valve job it, rock and roll. Alright, so we're done. You can see that this is resurfaced. It has a couple sample or just test hoop grooves in it that Brock already did before we started milling this. But I got one little spot right there that's not going to clean out. So we're going to have to take this back out of the machine. I'm going to add a little bit of weld there. And we'll throw it back in the machine and finish cutting this, reset it all back up. And we'll go from there. I have to show you this too, because on the Rottler here, they have this super cool, I mean, this thing is awesome, this little dual leveling table, so it goes up, down, and left, right, and this wicked fast bubble level, and we'll show you how accurate this thing is, because it's crazy. So Brock's gonna grab the level, we'll put it on here. Might have to mess it up just to. Reset. Well, this one's a little bit off right there. Let's see if I can get you a shadow. Just Yeah, pretty close. I mean, it's maybe off one line, which I think is like really minimal. So we just took it out of the machine, put it in the machine. We'll run an indicator across it because we would just turn these two handles to make the levels or make the bubbles level. And this thing is, you saw it. I mean, that was it. I mean, you just put it in the machine, clamp it down, set your little stands up, level it, and we'll show you how flat this is just by this. And we'll go into it and do the hair corrections because we could have made it even more perfect with the bubble level. But as you see this, that is dead nuts. It cracks me up. I mean, anytime you can take something out of a machine and put it back in and not have to re-indicate it in, that is, for something that is as simple a setup as this, it is just amazing. And if it was off, like I said, we unlock the table, turn handles until the bubbles are right perfect in there. Done. Amazingly quick, easy. So we can see here, I just added weld. We will, that should be pretty good. It's only about 5 high. I hammered that down. And that's probably about 10 high. About 10 high. So we'll get that down. And then next thing you'll see us do here is we're going to cut the hoops in the cylinder heads. Then we're going to valve job them. Alrighty, so we have, or actually Brock has, I haven't, done a little test cuts on there. You can see this one here. This is the one that we welded up. Looking great. So I do a test cut to verify our hole sizing. If we have to do any modifications or alterations to the sizing to make the hoop fit correctly, we would do it then. That's all done. So I'll show you how this thing just kind of comes down and cuts. Really quite nice. Bring it down, stir her up. Here in just 1 second, you'll see it start to cut. And these are really super nice finish and cuts really clean. There you go. Now this is going to be cutting 60 thousandths total depth, which leaves us 25 thousandths above surface for protrusion into the gasket. And as soon as it gets done cutting, the old rattler just goes over to the next holes, and then it's done, ready for valve job. Just about done. There we go. Comes up, moves over to the next one. And there you go. Next stop, the old Rattler head shop. Alright, so we're back over here on Ben Black's Viper V10, and I thought I'd share just a couple little things with you. So you can see here, we are cutting for a 2125 valve. Now, so I have lots of valve job videos and stuff out there, but we'll show you quick stuff here of how it cuts and whatnot. But one of the things that I thought you would be interested in, and one of my little pet peeves, is so this is basically the valve that came out of it. It's an 8mm or 5/16 valve stem. All right. Now, this is one of these little thinking parts, all right, and the valve's fine. 5/16 stuff is typically okay, but this, our typical valve that we'll be putting in something, this is a Victory 11/32 valve stem. So even if we're the same diameter up here, which we're not, we're actually bigger. This is a 20 something, I can't remember. I'll measure it up here in a minute. But anyways, the point is the valve stem. So cylinder head porters, typically think of, we are trying to make the best flowing cylinder head in the universe. That's cool. But I'm trying to make something that doesn't break, that doesn't have a problem. Okay? I will sacrifice, because Boost fixes everything. Sure, it's available. But if this valve here, this 5/16 valve, if it was the exact same diameter and it flowed 5 CFM more, now there's a weight deal, so don't get your panties all bunched up just yet. But if this valve stem or a cut down neck flowed 5 CFM better than this valve, who freaking cares? This is much stronger. This is a much stronger valve stem wise, valve head wise, this whole area up in here, than what this is. Simple fact. It's just material. There's more material there. It's stronger, period. Now, is it heavier? We could weigh, this one happens to be a steel valve, this is titanium, so I don't even have a direct comparison to give you right at this particular second. But even weight-wise, with smooth profile camshafts, now this is boosted stuff, okay? This is not NASCAR Cup stuff. This is not Pro Stock. This is not some big NA class stuff. There are just little subtle differences for all that. Okay, but this is boosted stuff. I don't care about 5 or 10 CFM. Could give a crap less. All I want it to do is be stronger and last. And we can get over the weight issue with the proper camshafts, with a little more spring. And we're talking minimal amount of spring, and actually the correct spring would probably be the same, given a slightly heavier valve. This valve in steel, if it was a direct comparison with its stem, maybe 5 to 10 grams, which is next to nothing. So always go for something that is a little bit bigger, just to bake for strength. That's what we really focus on, because we'll sacrifice that little minute deal for strength. Because you could have the best flowing head in the universe, like I said, but who cares if it breaks a valve? Who cares if you can't put a big enough push rod in it? Who cares if you can't, who cares how good it flows if you can't put those things in there? Or who cares if you can't hold a rocker arm on it? A lot of those things. All right, now the other thing we got to do here, because this is a combustion chamber that we welded and fixed, the hoops are in this, we're valve jobbing right now. I just increased the size of the valve guide, because this already had a 5/16 bronze valve guide, and all I did is I went through and made them 11/32. Revalve jobbing, and then we're going to be plugging all of our water holes here, and I think I talked about that before to you, that we're just going to tap and plug all of these water jacket holes, because we've made this a dry deck engine, so no water transfers between the block and the heads. Now we go over here to the block too. The other thing, it's a little dirty right now, don't mind that, but receiver grooves are in, sleeves are in, honed to size, deck to size. Now we have put in a 9/16 head stud. So we've drilled, tapped, and put a 9/16 head stud. All the water jackets are all blocked off on this. So what we'll do is we'll run water from this port, probably increase the size of that a little bit too, but we'll run water from this port up to the cylinder head, and then it'll flow exactly the same direction, exactly the same way. It just won't have a lot of water coming, or won't have any water coming up through the head gasket. So good stuff there. I'm getting this thing cleaned up today and putting it in an assembly stand, and finishing up cylinder heads right now, and we will be showing you more. Stainless steel hoops haven't been put in yet, but they're all machined up for it. I've done all the port work on them. I've just finished I've just finished blending in. Valve job, getting that all done. Has our Victory titanium intake and exhaust valves in it. And see, there's a little difference there, but that's okay. You can see the old repair, so you saw a bunch of the work that we had to do in order to fix this. And then everything is dry decked here. On the cylinder head is really easy because then we can just use tap and actually machine plugs into it to keep water out. So water will no longer be crossing over through the deck. Has a proper head gasket on it, has the proper O-ring, fire hoop, fire ring, whatever you want to call it, and receiver groove in the block. So that's going to be a ton better than what was already set up on this. And so we're just continuing to plug away and get everything rocking and rolling. Sorry, I'm getting distracted by numbers as I'm reading them at the same time. So anyways, we're going to keep on going on. Should be having this thing done hopefully today. Now we've gotten this thing mocked up. Now we're doing final assembly on it. I've had several little issues trying to figure out. One of them, just the silly, dumb things that happen all the time. Getting that bottom gear off of this, the stock bottom gear that was on it. What a mother that was. Finally got that all changed over, and then we put the camshaft together. So this is a little bit interesting. This is the first time that I've ever seen this. So we went to mock up the camshaft, make sure everything fits and works. And Joe goes, hey, the camshaft lifters don't line up with the lobe. It was like this. So it was like over to the side instead of in the middle. And the lifter would come over and actually just touch the other lobe on it. So obviously the camshaft was in the wrong spot. Well, the camshaft is controlled by thrust. And then it's like we start just really checking it and putting everything all together. Found out that all the journal sizes are right. The cam lobes are correct. They forgot to, not the cam grinders, but probably the core manufacturer forgot to grind that surface right there to finish it to depth, and left this at a rough size 15 thousandths larger. So we had to, which I'm not necessarily tooled up to do all this. So that took me a little while, so we had to, so I did end up being able here in-house to face that flange where it sets thrust, which is right here, and turn this size all down, all so it would fit the top gear, and then have the correct amount of thrust in it. Because what it did was it had no thrust in it because they didn't have this cut enough, and so it was forcing the camshaft backwards too far, and we couldn't get the top gear on properly.
And we thought we were out of the water once we made the cam gear fit, and then once we put the cam gear on, then we had no thrust, and then realized that we had to pull it out again.
Yes.
Machine that surface.
Yes. Yeah. So it's actually, that's actually a two-part deal. So yes, we made the top gear fit first, and then which is a real rarity because that camshaft sets in here and uses this portion of the top gear for thrust, and then that all sits against the brass plate. So yes, it was a cluster cuss, but got that all fixed. So some simple little thing. Who do you call and complain to? Nobody. You just fix it. So the then one of the next things it did was had put 9/16 head studs in it. You want to roll this over real quick and show them. They put 9/16 head studs in it. So Ben wanted me to put 9/16 head studs in it, which is cool. That's a really big head stud, and so we did do that, and that makes me have to machine up these 30. I think they're 25 or 30 thousandths thick.
I think they're 30.
I think they're 30. Yeah, I think they're 30 thousandths thick dowel pins, because now the stud is 9/16 ID hole, and the dimension of that. So I'm over there making these things on a lathe. So get the camshaft all fit on the lathe, get this to fit on the lathe. We had a problem.
Right, 24,000.
24 thousandths. Yeah, see, that's pretty good. So made the dowel pins right there. I did have a long story. I'm not really going to get involved in it too much, but I had a bad head stud, and I have now spent, me and Brock and Joe here have probably spent a grand total of, well, 2.5 days fixing a broken head stud. But anyways, everything is done. It's right. Now we're going in for final assembly. Oh, and I did do, this is where water is now going in. I can't remember if I showed that to you or not, but water is going to go through the block, out this passage right here, which is factory. So it's going to go out this passage right here via a short line. You want to just grab that head and just set it up there. It's going to go through a short line. I'm going to let Ben or whoever's doing the install figure this one out, because I'm not going to bother making something that might get in the way. Basically, it just goes from here up to here. So this will have a dash 12 fitting in it, and they'll probably maybe loop it or do something funny, but it's going to come out here, it goes in the cylinder head there, and then does its entire water process through here. Now, I didn't perfectly match this all up, because it just wouldn't look right anyways, but these are actually, this is where I was thinking I was going to put the fitting before. There is no water back there. So I just welded up these little holes. Actually, there's water on this one, but I couldn't put a fitting there. So I welded up these 2 holes. They were just test holes. So it's like drilling for oil, except I was drilling for water passages. And so I just welded those up. I'm not going to make them look perfect, because I can never make it look perfect anyways. So that's all the water. Valve train is all on it. We've already got everything all mocked up with lifters, correct push rods, with spares for Ben. So we are finally on the total assembly side, and so we'll show you the whole assembly. And then we're not dynoing this. We're going to be sending this out to Ben, and Ben's going to be installing it in the car and doing hub dyno work with it. So keep on watching. We'll get this thing all together, and once it's all done, we'll give it the once over, put it in a crate, and send it out. Oh, let's go over here, look at upcoming video, all billet SML. Just like we talked about in the previous video, let me show you something here. So this is for engine that we're doing for a sick week / drag week car of Jason Sack. If you look at the polish and fit and shine on all of this, because Jason Sack is a fanatic about how stuff looks, this stuff is really cool. So I am working on and doing the full build-up video with dyno, 3,000 plus horsepower, LS drag and drive bulletproof combination, all coming up this next week. right, now you just saw the entire assembly process. Now, the one thing that we didn't show you a lot of, or very much of, was how many times we've already had this together. So you're seeing, you didn't see us check the bearing clearance. You didn't see, actually Joe checked the bearing clearance. You didn't see degree in the cam. You didn't see all that stuff because he's done all of that already. Actually, you probably did you read degree?
I read degree.
Yeah, read degree to cam. So you did see that.
Just to make sure.
But bearing clearances, all the stuff's already been all mocked up, has already been test fitted, and then disassembled, and then you came in here to see the final full assembly. So it has this thing is going out to A&C Performance in California. Know where that's at?
I think so.
All
I've been
right.
there before.
It's a 951 area code. Anyways.
Oh.
And so this thing is finally all done for Ben Black. I think it's going to be really good. It definitely is dry decked. You can see here. So they'll figure out how they want to do this. A dry decked, really good sleeve, gasket, fire ring, hoop combination, our camshaft package, piston and rod package. Should be a very good piece for them guys to start working on and sorting out the tune. So anyways, I am Steve Morris, Steve Morris Engines. Have like, subscribe. Oh, we got, oh no, let's see what else. No, we don't have anything else in.
No.
All right. Have a great day.